Physics, Chapter 3, Mechanics or Liquids. Section 3, Archimedes Principle, by Willis Eugene Tower, Charles Henry Smith, Charles Mark Turton, and Thomas Darlington Cope. Coffee break collection number 25, Water. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to learn how to volunteer, please visit LibriVox.org. Archimedes Principle. A body supported by a liquid. Among the applications of the force exerted by a liquid upon a surface, Archimedes' principle is one of the most important. Most persons have noted that a body placed in water is partly or wholly supported by the force of the water upon it. A stone held by a cord and lowered into water is felt to have part of its weight supported, while a piece of cork or wood is wholly supported and floats. The human body is almost entirely supported in water. In fact, many people can easily float in water. It was the consideration of this fact that led the Greek philosopher Archimedes to discover and state the principle that describes the supporting of a body in a liquid. Archimedes' principle. A body immersed in a liquid is pushed up by a force equal to the weight of the liquid that it displaces. The proof for this law is simply demonstrated. Suppose a cube ABCD is immersed in water. Figure 25. The upward force on CD is equal to the weight of a column of water equal to CDEF. See Art 39. The downward force upon the top of the cube is equal to the weight of the column of water ABEF. Then the net upward force upon the cube, that is, the upward force upon the bottom, less the downward force upon the top, or the buoyant force exerted by the liquid, is exactly equal to the weight of the displaced water A, B, C, D. Law of floating bodies. This same reasoning may be applied to any liquid and to any body immersed to any depth below the surface of the liquid. If the body weighs more than the displaced liquid, it will sink. If it weighs less than the displaced liquid, it will float or rise in the water. A block of wood rises out of the water in which it floats until its own weight just equals the weight of the water it displaces. From this, we have the law of floating bodies. A floating body displaces its own weight of the liquid in which it floats. To test the law of floating bodies, take a rod of light wood, 1 centimeter square and 30 centimeters long. Figure 26. Bore out one end and fill the opening with lead and seal with paraffin so that the rod will float vertically when placed in water. Mark upon one side of the rod a centimeter scale and dip the rod in hot paraffin to make it waterproof. Now, find the weight of the stick in grams and note the depth to which it sinks in water in centimeters. Compute the weight of the displaced water. It will equal the weight of the rod. Applications of Archimedes' principle. There are numerous applications of Archimedes' principle and the law of floating bodies. A. To find the weight of a floating body. Problem. A boat 20 feet long and with an average width of 6 feet sinks to an average depth of 3 feet in the water. Find the weight of the boat. What weight of cargo will sink it to an average depth of 5 feet? Solution. The volume of the water displaced is 20 times 6 times 3 cubic feet, equaling 360 cubic feet. Since 1 cubic foot of water weighs 62.4 pounds, 360 times 62.4 pounds equals 22,464 pounds, and the weight of the water displaced. By the law of floating bodies, this is equal to the weight of the boat. When loaded, the volume of water displaced is 20 feet times 6 times 5 feet, which equal 600 cubic feet. 600 times 62.4 pounds equals 37,440 pounds. This is the weight of the water displaced when loaded. 37,440 pounds minus 22,464 pounds equals 14,976 pounds, the weight of the cargo. B. To find the volume of an immersed solid. Problem. A stone weighs 187.2 pounds in air and appears to weigh 124.8 pounds in water. What is its volume? Solution. 187.2 pounds minus 124.8 pounds equals 62.4 pounds, the buoyant force of the water. By Archimedes' principle, this equals the weight of the displaced water, which has a volume of 1 cubic foot, which is therefore the volume of the stone. C. To find the density of a body. The density of a body is defined as the mass of unit volume. We can easily find the mass of a body by weighing it, but the volume is often impossible to obtain by measurement, especially of irregular solids. Archimedes' principle, however, provides a method of finding the volume of a body accurately by weighing it first in air and then in water. Figure 27. the apparent loss in weight being equal to the weight of the displaced water. One needs only to find the volume of water having the same weight as the loss of weight to find the volume of the body. If the metric system is used, 1 cubic centimeter of water weighs 1 gram, and the volume is numerically the same as the loss of weight. End of Physics, Chapter 3, Section 3. Archimedes' Principle.